Okay, I'm going to start on the second part of Lab 3. Now that we have our data loaded, we can make some pretty pictures. We're going to use the ggplot2 package, which is part of the tidyverse, but we're going to load it explicitly. So that's the first thing we're going to do is our next line. My next line is going to be that I'm going to type something in to show that this is a different part of the lab, uh, data visualization. Then I'm going to type a comment that I am going to load ggplot2, and then I'm going to actually load ggplot2. Uh, so you don't have to do the comments, but I really encourage you to do comments that will help you come back later. If you go try to apply this stuff to your own data, which you are going to have to do before the end of the semester, um, and hopefully you will start doing with this lab assignment, um, that you remember what was going on. So I'm going to load ggplot2. That doesn't really do anything. All it does, you won't see any kind of response unless there's a problem. But it is loaded now, so we can use it. So the next thing I'm going to do um, is we want to create a histogram. And so we're going to create a really simple histogram, a really simple example, create a histogram of the variable x5 from the that data from lab 1. So it's x5, it's from my data loaded. And so the first thing we've got to do is we need the ggplot function, right? So I just created the ggplot. I typed ggplot parentheses. I'm ready to start that function. And the first thing I have to do is tell it what piece of data it's working with. And in this case, I want it to work with this piece of data up here, that data from lab 1. Um, the second thing I have to do is I tell it what inside that data I want it to work with. And I want it to work with x, and that's a lowercase x, which just and I want to tell it that I want x to equal x1. So I actually up here I said x5. This is x1. Uh, so what this AES stands for aesthetic. Um, this is a little bit um, it is a little bit confusing, maybe if you don't understand what we're doing here. Why is this called AES? So I didn't understand it for a while. I'm still not sure why they choose to call this aesthetics. But the aesthetic part of it is we're making this what we're putting on the x-axis. So it's telling it's telling ggplot in this place, in this area, I want you to do this. And so what it's doing is it's assigning this variable to the x-axis. The next thing we're going to do is, I'm sorry, it is not a comma, it is a plus. And the plus tells it we're not done yet. We've got more to do. And we're going to go to the next line to do it. And so here we're going to use geom histogram, which stands for geometry histogram. This tells RStudio and the ggplot function in RStudio that that we want to create a histogram. And as we do more of these, there are other geometries we can use. We can use point and plot and no, I'm sorry, point and dot plot and line, and actually there are quite a few different geometries we can use. So we're going to use geometry histogram, and then we're going to tell it the bin width equals 1, which really is just what it sounds like. Every every bar in our histogram is going to be one observation, or one variable in this case. Uh, so, so I really messed this up in the lab. I put x5 and then I put x1 as what I was going to use, and then I made it histogram of x5. That's wrong. So the next line, you can you can change it either way. You can either fix it here or you can fix the labels. The next part is the labels. And the title, the title is just what it sounds like. It's going to be what we want this thing to be called. I want it to be called histogram of x1. The next one is x equals x5. And that just tells it that I'm labeling the x5 or the x-axis with x5 because that's what my x variable is, and then the y-axis I'm going to label frequency. So that is to say what I'm making is a frequency graph, a graph of how often a particular variable shows up, and or not a particular variable, a particular numeric observation for the variable shows up. I'm going to come down here to the console and view that data, just so we get an idea of what we're actually talking about. So if it's x1, there's one observation of 1, an observation of 6, and an observation of 11. If we were to make it x5, it would be an observation of 5, an observation of 10, an observation of 15. But we're only doing x1, and it's 1, 6, and 11. There's one observation of each of those numbers. So what we should expect is that we'll get a histogram that will have a value of 1 for each of those numbers. And so I'm going to run it. It's going to pop up over here. And so you got lots of different things down here. One of them is plots. If you do a new plot, it should pop up over here. And so what this is saying, so this is the point that is 1, the number 1, and it occurred one time. Number 6 occurred one time. Number 11 occurred one time. This is just what we should expect to happen. This is a plain Jane histogram. It is as bare bones as we can get. It's gray. It doesn't have any color. But this, you start with the simple stuff, and then we'll add to it. So we start with the simple, and we're going to add. We will get there. By the end of this, we'll have some things that are definitely a little prettier than this. And you can make prettier histograms. So what's our next thing we're going to do? Next thing we're going to do is a scatter plot of x1 versus x2. So this is actually getting to one of the things that we're eventually going to want to do, which is put a line. It's to show how the variables relate to each other. So we could say that x1 and x2, one of them is, even though they're both named x because of the way we named it, one of them is our causal variable that's on the x-axis, and then one of them is our independent variable that ends up on the y-axis. And so that's what we're going to do here. We're going to start with that same thing again, ggplot, and it's not going to, we're going to be referring to the same data, so that doesn't change, but our beginning aesthetic changes. And we're going to go x equals, I'm going to try to do this one actually right completely. So x equals x1 and y equals x2. So it's telling ggplot on the x-axis we're going to have x1, the y-axis is going to be x2. The next thing that we need to do is hit that plus to tell it there's more. We're not done because we closed our parentheses, and so if I don't hit the plus, that's all it's going to do. We want to do more. We want to add more to it. So the plus gets us there. And so the geometry I'm going to use here is point. I want it to be, I want it to just draw points, dots for everything. And I'm not going to do anything special with that point geometry. So the parentheses stays blank. There are some things we can put in there, but I'm not messing with that right now. I'm just going to leave it. It's going to be very plain. It's just going to create dots. But then I do want to do some labels. So I'm going to do a label with a title of scatter plot of x1 versus x2. And I think the convention is you put the variable on the x-axis first, the variable on the y-axis second. So that's why I say it is a scatter plot of x1 versus x2 and not the other way around. And I want to label the x-axis with what it is, it's x1. And I want to label the y-axis with what it is, it's x2. This is just to create the labels. I have an unmatched opening bracket. That's not good. I don't know that, that, that. No, I don't. I have to figure this out. So give me a second. Okay. Yeah, there wasn't anything. Something was, well, yes, there is. What is it? All right, I'm going to come down here and just try again. See what happens. I, comma, AES, X equals. Ah, now I know what my problem was. It wasn't a bracket, it was an unmatched quotation mark. So I left the quotation mark off the end of X2. And sometimes just starting to type it again is your best way to find things. Uh, so, um, so we've created a scatter plot. This is the first point. It is, and if we go look, we can see, so this is, the first point is 1, comma 5. No, not 1, comma, is 1, comma 2, right? And so this is starting at 2. It doesn't show anything below 2. And we can fix that if we do something like this again. The second one is 6, comma 7. So this is just below 7.5 actually. And then the next one is 11, comma 12. So it's plotting 1 versus 1 on the x-axis, 2 on the y-axis, 6 on the x-axis, 7 on the y, 11 on the x is 12 on the y. And they actually form a nice straight line, and that's because of the way we created that data. It was the original data was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So it created that data. Um, so um, the next thing we're going to do is create something called a dot plot. And this is actually going to be very similar to a histogram, but it's a different geometry function, and we're going to create it for GDP per capita from the VDEM VDEM indices. So a dot plot. Um, and so we're going to start with ggplot again. Here's where we're going to change something in the first. We're picking a different piece of data set. Then our AES is going to be different. Our X is going to be GDP per capita. And it is just GDP per capita because we gave it that nice, easy name. And then we'll come out here and put this plus sign so that we can go to the next line and start typing. The geometry on this is going to be dot plot. It's geom dot plot. But this time we are going to type something inside the parentheses, and it's going to be a bin width. And I'm going to set the bin width equals to 5. And what that's going to do, actually, it's going to represent that each of our dots in this dot plot is going to represent 5 times that a particular observation has been observed. So we've got 179 observations of GDP per capita. Our dots, we'd have an awful lot of dots if we set bin width equal to 1. So we're going to set bin width equals to 5. So we get 5 observations for each dot. And then for our labels, our title is going to be dot plot of GDP per capita from VDEM for 2014. We can name it whatever we want. I didn't name it. Yeah, let's see. I did dot plot of GDP per capita. Okay. So then the X, I want it to be labeled GDP per capita. And then the Y, I want to be labeled frequency. The same as our histogram. I'm going to come back here. I could put a return in there as long as I haven't actually closed out the bracket. I can put a return in there if I'm careful. If you do that and you see a red dot come up, just backspace delete until you get back to where you did the return, till you get back to that previous comma, and make sure you don't have something in there that broke it. But so that we have everything on separate lines, I've done that. And now I'm going to run this. And I named it wrong. What is it? It's not GDP per capita, I guess. Yes. I made a typo. I called it GPD per capita when I typed it. So I can solve that one of two ways. I can go back and rerun up there to make this right, or I can just do it here. Since I'm going to label everything anyway, I can just run it. So I got the GDP per capita. It looks kind of like a histogram, but it's with dots. And so each dot shows us 5 observations, which makes it a little bit easier. Like here, we know it's not exactly 0.25 because we know these are 5 observations. So this is actually 0.225. This is actually the range from this is the range from halfway below 0.25, like 0.225, to 0.275. So the dots help us to get a little more fine-grained than when we get with a histogram. That's the only real purpose of them. or I mean, I guess that's the main purpose. It just gives us a little bit more fine-grained information. Uh, Now we'll do a histogram of the GDP per capita. So we're going to do a histogram of the same thing, um, which means since we're starting with the same stuff, the first command is going to be that, and then the aesthetic is going to be the same, x equals, and we got to remember that I typed it wrong, so I'll type it right again, type it wrong again, so it works. GPD instead of GDP. But then where we change things, I'm going to create geom, histogram, uh, and I still want the bin width to equals 5. So it's going to look fairly similar. And then the labels. Um, when I started doing this, I was thinking about doing log GDP. Don't worry about that. That's not right. I should have changed that. The title is actually going to be histogram of just GDP per capita. I'm not gonna type out a longer title. X equals um, GDP per capita and Y equals um, frequency. I'm going to put that on a separate line. And so you can see the histogram looks very similar. Within this plot window, if I want to move through the plots, I can use the arrows to do so. Yeah. So so there's so that's the one that was a mistake that didn't produce anything. So the dot plot looks like this. The histogram looks like this. Um, put a note in here, create a histogram of the same exact thing. Um, Now the next thing I want to do is maybe make something uh, different, have some different color. And so I'm going to create a histogram of the polyarchy variable with some color. And so ggplot is my same starting point. I'm still going with the VDEM indices. My AES is going to be different because I want polyarchy. And one of the ways that I can make sure I don't have a typo in this, that I actually get the real thing, is I can start typing and you can see polyarchy from the VDEM indices 2014. So that's good. Put my plus there. I want it to be a histogram. Again, I'm going to go with the same bin width. Bin width equals 5. Come out here. I want to do some labels. Title equals histogram of polyarchy, and X equals GDP. No, X equals polyarchy, Y equals frequency, but I didn't add any color. So where do I do that? So I need to add some color. And where I'm going to add color is actually in the histogram geom. And so I can add two things. One, I can add fill, and I'm going to add fill equals, let's see, fill equals blue? No, fill equals blue. See if I can get this right. There we go. When you get it right, if you're using RStudio, you'll immediately know, because if it's one of the colors that there is a name for, it will pop up in that color. And then color equals black. So fill is blue. Fill means what's going to go in here, and then color is to draw borders around it. So we'll run that. That didn't work. I think I need a little bit lower bin width. So I created it with a bin width of 5, and it just created this big block. So let's go with a smaller bin width. If I go with a bin width, there we go, a bin width of 0.1. Why did that happen? Well, because the polyarchy score runs from 0 to 1. So when I ran it with a bin width of 5, everything is from 0 to 1. That was actually 5 times as big as the full possible data set. So I go 0.1, it divides that 0 to 1 into 10 equal bins. And so I get that. One of the things you may be noticing is these are not very normally distributed. And that's not really surprising. We'll get to that in a minute. But first, one of the things we'd want to do is to create, we want to start fitting lines to data. And we don't want to just draw lines through the data. Anybody can do that. What we want to do is find the linear equation that's going to find the line that fits the data with the least amount of error. That's called ordinary least squares regression, at least the way we're going to do it. And when you do ordinary least squares regression, you come up with some data tables that give you information you can use to create that equation. And more important, or just as importantly, they also tell you whether the results are statistically significant. So it's not just drawing a line, but one result is you come up with the numbers you need to fill in to the equation for a line, that y equals mx plus b. You get the m and the b. You get the m and the b, although we call them alpha and beta, but still you get them and you can draw a line. For visualization purposes, you're going to actually want to be able to visualize that. And you don't really need to understand the equations in order to do that, because R is going to do that for us. Statistically, you need to understand where it comes from. But we're going to create a scatter plot with an LM line. And so the first thing we're going to do, same thing, we're going to do ggplot. We're using the VDEM indices still. Our AES is going to be GDP per capita versus polyarchy. So if I say that GDP per capita is on the X line and that Y is, I got to do it right though because I misspelled it, and that Y is polyarchy, the implication I'm making is that in my theory, I think that a country's GDP per capita is going to be the thing that causes or influences its polyarchy score. I'm not proving it, I'm just drawing a picture that says so. And when we draw a picture that says so, we put the independent variable on the x-axis and whatever we think is the dependent variable on the y-axis. So I've done that. The next thing I want to do is do geom point again, but this time I'm going to fill some things into it. I want to make it look a little better, so I'm going to do an AES, another aesthetic. And in this one, I'm going to give it some color. And so I'm going to have every different country have a different color. And I want I want to actually show a third variable here, which is the population of the countries. Potentially, that potentially could be a compounding variable. Maybe smaller countries are inherently more democratic or inherently less democratic. We'll be able to see because the dot size is going to actually represent the population. And then to get the line, I'm going to use something called geom smooth, which just is, it's going to draw a smooth line, a smoothed line. And I'm going to tell it method equals LM, which just means to use a linear model. And I'm going to tell it SE equals false, which just tells it that I don't want it to reflect a standard error, which is something we're going to talk about in the next week to two. What is a standard error? But we don't want one. We don't want it to draw. We don't want it to draw these sort of how confident we are in the data. We don't want that. We just want the bare line. So title equals, I'm just going to name this scatter plot of GDP per capita versus polyarchy score. Okay, and then I'm going to put X equals GDP per capita, Y equals polyarchy score, and hopefully I typed everything right. I don't see any big errors. Yeah, there we go. Oh, well, that did something weird. Yeah, I did something wrong. Uh, oh, okay. I need to add this. So what that all is the legend. This is telling you what all the different colors mean. And because there are 179 um, countries, it's a really big legend. If we expanded this, you'd see the full list of countries, and then you would see, um, and then somewhere in that plot, you would actually see this, which is what we're going for. So see, we have a pretty big country down here, pretty big country here, a little bit smaller country here, some really little countries out here and here. But as GDP per capita increases, um, the overall slope of this data is that as GDP per capita increases, um, polyarchy increases, which is actually a relationship that we know is true. Um, Democracy and GDP per capita are correlated, so that's not a surprise. But we made a much more visually appealing, and there's more information because we've got three variables on this graph. Actually, four, if you include the fact that we have the different colors for the countries. Um, we could do different colors if we had, for example, continents, and we did it by continent. We did color equal continent, which we don't have that information up here. But if we had that information, we could color by continent, and we could leave the legend, and it would be much smaller, and we'd be able to see which continent each one of these was on. So that would actually give us four variables in the graph: GDP, per capita, polyarchy score, population, and continent. Here we just have country, and it's not as useful, but it is nicer looking. Um, so the next thing we want to do is uh, um, we can do we could do the same thing with um, liberal democracy and imports, right? So I'm just going to copy and paste this and hope it works. And you're free to do the same thing. I just don't want to make you wait while I type everything. So we've got that. Um, so Okay. Uh, so it's all the same until we get out here. I changed the variables. I changed GDP per capita to liberal democracy. I changed polyarchy to imports. So the claim I'm actually making here is that liberal democracy is the independent variable, the cause, and imports is the dependent variable or the effect. I'm still coloring by country. I've still got size by population, and I'm still leaving the theme out so that it'll look good. Um, and I'm still doing the smooth LM line. And look at that. Liberal democracy, as it increases, I mean, you can see the relationship. that imports increase, except for this one really big country. Uh, so uh, so that has a lot of imports and very low liberal democracy. Um, that's probably China. That's probably China. I don't know. We could find out. Maybe we'll find out in a later class. But that's a country that has very low liberal democracy and very high imports. But if you look at all the others, the data really is it's a rising line. If we eliminated that outlier wherever whatever it was, the slope of that line would even be higher. So that's interesting. Um, so now we're going to use the Gapminder data to tell a little bit more complicated story with a histogram and a different kind of line. Uh, use Gapminder to create a histogram with a normal curve overlaid. That's what we're going to do. So first, we're going to do ggplot again, but this time we're using the Gapminder data, and we're going to use as our AES X variable, we're going to use life expectancy, and it's lowercase LIFE, uppercase EXP, but if I start typing it, I can see it here, and I can click on it. Then I'm going to go plus because I want to add something. And what I want to add first is my histogram geometry. And inside of that, I'm going to create an AES where y equals density. And what that does is that instead of being a frequency histogram, this is now a density histogram. I'm going to set my bin width equal to 5. I'm going to set my color equal to red. No, my fill color equal to green. And I know that worked because it lit up green. I'm going to come back to this comma and take this down to the next line. And I'm going to make my color equal black again. Because I've got dark mode on, it didn't change to black, but you can see as soon as I finish typing the word, the color changes a little bit. Um, so, um, and then I'm going to do the plus sign again uh, and hit return again. And I'm going to do my next line, which is I'm going to do a statistics function. I want this to have a a a a normal distribution in it. And so in order to do that, I'm going to do the statistics function dnorm. And so I tell it fun equals, and this is a lot of fun, but what I'm actually telling it is I want to use the function dnorm, and then arguments equals args equals, and I'm going to give it a list of mean args equals, and I'm gonna give it this list. So mean equals the mean for Gapminder data life expectancy. The standard deviation is the standard deviation from there. So I'm telling it that, and so what I'm doing here, so the function is the normal function. The normal distribution, that's actually a function for the normal distribution. That function has, as two arguments, you have to tell it what the mean and the standard deviation are. Because if you remember, a normal distribution is centered on the mean, and the width is determined by the standard deviation. So for the function, you have to tell it the mean and the standard deviation for it to draw it. and we're going to color it red and give it a size equals 1. Color equals red, that worked. Size equals 1, that just tells it how big I want the line to be, how thick I want the line to be. Um, and then I'm going to put some labels. So labels, title equals histogram of life expectancy with a normal distribution. And then I'm going to tell it x equals life expectancy and y equals density. So it's not the frequency, it's the density, which means it's just a different way of visualizing it. Y equals density. And then, yeah, we're done. If that worked right, we should get this. And so this is the actual distribution. The green is the actual distributions of life expectancies among countries. This is what a normal distribution would mean. Does that mean there's something wrong? Not at all. Not at all. There are good reasons we would not expect it to be normal. If you reach a certain age, for example, if you get past infancy, you have a higher probability of getting to a higher age. So the life expectancy, we wouldn't expect it to be normally distributed. There are lots of reasons it wouldn't be. Could it mean that there's something going on that's wrong? Maybe, but not necessarily. But it is useful to know that. Why is it useful to know it? Because it means we can't apply the normal distribution to tell whether there is something wrong, because the probabilities are not based on the normal distribution. So it's actually a kind of a useful graph. It actually allows us to visualize something that's pretty important. So here's more of a description. I described this, some, but more of a description. So before we meet for Lab 4, you have an assignment to do. First, you're going to practice creating plots by loading a data set of your choice, preferably the one you want to use all semester. You are free to use the Gapminder data set, although it's very simple. You're free to use the VDEM data set. It has lots of things. And so down here, I linked to the VDEM codebook in case you want to go pick different variables. Now the key is you've got to create three plots that are different from the ones that I created. So you have to create 3 different plots, either by picking a different plot entirely with the same variables, by picking the same kind of plot but putting in different variables. You should create them from the same data set, whatever data set you want to use. You also need to, from the same data set, find the mean, median, variance, and standard deviation of at least 2 variables. I've put together and already posted before this one 2 videos to help you with saving the plots so that you can save them and put them into a Word document, and creating the tables using something called the Stargazer method. So you can use the method we used from Lab 1 by itself, or you can make a little bit neater tables with the Stargazer method or some other R method. If you do that, you'll get 5 extra points on this lab. Just doing something in Microsoft Word to make a table where you do it manually, that doesn't get you any extra points. You need to actually put the code that you used in your Word document to show me how you made the table. So if you can make a little bit better table than what we did with Lab 1, either using Stargazer, which I'll show you in another video that's already posted, or some other method, and there are other methods out there, and do it in R, then 5 extra points. Time-saving hints. You're going to have to do all of these things on that final project. So your best bet is find your data source first. and then do this and do it with the data you're going to use on the final project. And the first two things you have to do for the final project will be done. Time saving hint there. You can do that. It'll save you time at the end of the semester. Um, any other questions? We will have some time in class and then, of course, office hours as always. Thank you.